Assalamu alaikum students. The previous lecture was about principal focus and focal length of a concave and convex mirror. Now we will go through some definitions which are really important to understand the image formation by concave mirror. Fine. We will go through the definitions first. The first definition is radius of curvature. What's the radius of curvature? Before defining the radius of curvature, we would go to the spherical mirror, the definition of spherical mirrors. The spherical mirror is made from a hollow sphere of glass. The spherical mirror is made from a hollow sphere of glass. This hollow sphere is cut and one of the curved portion of the hollow sphere is left from which the mirror is made. Like this portion is left and we silver this portion from the inner side and it becomes a concave mirror. If we would polish it with silver from this side, then it would become a convex mirror. Now this mirror is actually the part of a sphere. This mirror is actually the part of a sphere. This sphere would have its own center. This sphere would have its own center, and that center of the sphere of which mirror is originally a part, the center of the sphere, which sphere of which mirror is originally a part, we cut that sphere, fine, and this curved portion remains there. This curved portion or this mirror, this spherical mirror, is actually the part of this sphere. Now this sphere would have its own center. That center of this sphere of which mirror is originally a part is known as center of curvature. Fine. The center of this sphere, of which mirror is originally a part, is known as center of curvature. Now this distance, which you already know, this distance of a spherical portion, what is it known? It's simply radius. Fine. This radius of this sphere of which mirror is originally a part, the radius of this sphere of which mirror is originally a part, this radius is known as radius of curvature. So we will define the radius of curvature as the radius of sphere. The radius of sphere, which sphere we are talking about, of which mirror is originally a part. Of which mirror is originally a part. Fine. This radius of this sphere is known as radius of curvature, and the center of this sphere, which sphere again, of which mirror is originally a part, is known as center of curvature. So the spherical mirror is actually made from the hollow sphere of glass. This hollow sphere would have its own center, and that center is known as center of curvature, and the radius of that sphere is known as radius of curvature. Now an imaginary line is passed through this center and this point, the center of mirror, known as pole. Fine. The center of this mirror is known as pole. Take midpoint of the mirror. Okay. An imaginary line is passed through the center and the pole of the mirror. An imaginary line passing through the center of curvature and the pole of the mirror. This imaginary line is known as principal axis. So what's the principal axis? It's that imaginary line that's passed through the center of curvature and the pole of the mirror. That line that passes through the center of curvature and the pole of the mirror, or which joins center of curvature and the pole of the mirror, is known as principal axis of the mirror. Fine. Now the total reflecting surface, this is the mirror, this is its reflecting surface. The total reflecting surface, this portion of the mirror, from this point, from point A to point B, APB, the entire reflecting surface The entire reflecting surface of the mirror is known as aperture. The entire reflecting surface of the mirror is known as aperture. Fine. So we came across a few basic definitions. The first was center of curvature. Now what's center of curvature? It's the center of the sphere of which mirror is originally a part. The second was radius of curvature, the radius of that sphere, and the third was pole of the mirror. Pole, that is the center point of this curved surface. Fine, midpoint of this curved surface, that is pole. And then principal axis, that is the line passing through center of curvature and pole of the mirror, it's called the principal axis. And aperture, the total reflecting surface of the mirror, is known as aperture. Now the topic is about the image formation. The image formation by spherical mirrors. Image formation. But before discussing the image formation and the characteristics of that image, that whether it's real, inverted, virtual, erect, fine, we have to discuss again a very basic topic, that is sign conventions. Sign conventions for spherical mirrors. Sign conventions for spherical mirrors. The sign conventions are 4 or 5 points. We will discuss this topic in 4 or 5 points. But the basic thing and very important thing about the sign conventions is that with the help of sign conventions, we get a numerical value. By putting these sign conventions in a formula, by putting these signs related to some distances, when we put these signs with some distances and we get a numerical value, and that numerical value, one single value, would give us the characteristics of the image. Listen carefully why we study these sign conventions. The sign, an algebraic sign, is put in front of a numerical value like distances, which we will discuss, fine, and we get a numerical value. Finally, after putting those signs in a formula, we get a final numerical value, and that numerical value would give us the different characteristics of image. So we would simply look at the numerical value, a single numerical value, and we would know whether the image is real, whether it is inverted, whether it is formed in front of the mirror or behind the mirror, below the principal axis, above the principal axis. So we would come to know about these characteristics with the help of a single numerical value. And in order to get that numerical value, we have to use some signs. Now what's the first sign convention? First sign convention is that an object is always kept to the left side of mirror. An object is always kept to the left side of mirror. So here it's a concave mirror, a spherical mirror, a concave or convex. An object is kept here. An object is always kept to the left side of the mirror. So this is the first sign convention. The second sign convention. All the distances are measured from pole of the mirror. When we have to measure some distance like this is a concave mirror, this is principal axis. The first convention is that we have to put the object on the left side of the mirror. Here I put the object on the left side of the mirror. The distance, if I have to measure the distance of this object, I can measure the distance from the center of curvature, from the focus, from the pole, isn't it? There are various points on the principal axis of the mirror, but we always have to measure the distance, any distance, from the pole of the mirror. That means I have to go in this way, by measuring the distance. Fine. So all the distances are measured. The reference point is taken as the pole. So what's the reference point for measuring the distance? It's the pole. So all the distances are measured from the pole of the mirror. So I have to measure, I have to take the pole as the reference point and measure the different distances. All the distances are measured from the pole of the mirror. Now third point. All the distances above the principal axis all the distances above and actually perpendicular to principal axis all the distances above and perpendicular to principal axis are taken as positive. That means once I place the object on the left side, here it is, object on left side. The next is distances are measured from the pole of the mirror. Now if I have to measure from any distance perpendicular to principal axis, this distance, the distances in this direction are taken as positive. So all the distances are measured above and perpendicular to principal axis are taken as positive. The first point was an object is kept to the left side of the mirror. All the distances would be measured from the pole of the mirror. So pole is the reference point. And if I have to measure the distance in this direction, the distances in this direction, that is above and perpendicular to principal axis, are taken as positive. So all the distance in this direction are taken as positive. Similarly, all the distances below and perpendicular to principal axis are taken as negative. All the distances below and perpendicular to principal axis, that is distances in this direction, they are taken as negative. Fine. So if I have to measure the distances in this direction, for example, I am having a distance of 15 centimeter. So I would put the sign of plus 15 centimeter. If I have to measure the distance in this direction, if I get the value of 10 centimeter, then I have to take it as minus 10 centimeter. Fine. So all the distances above principal axis positive, all the distance below principal axis negative. Fine. The next point. I have placed the object on the left side. So what would be the direction of incident rays? The direction of incident rays would be this. Fine. This is the direction of incident rays. The rays coming from the object and falling on the mirror. Fine. This direction, if the distances are being measured in this direction, towards right side of the object, towards right side of the mirror, if the distances are measured in this direction, all distances in this direction are taken as positive. All the distances measured in this direction are taken as positive. So I would write all the distances in which direction? All the distance in which direction? In the direction of incident light. It's an object, the rays would fall on the mirror in this direction. So this is the direction of incident rays. So all the distances in this direction, all the distances in the direction of incident rays are taken as positive. All the distances in this direction, all the distances in the direction of incident rays are taken as positive. Now, what would be this direction? What would we call this direction? It is simply opposite to the direction of incident rays, isn't it? Incident rays are in this direction, towards right, and towards left is opposite to incident rays. So I would write all the distances opposite opposite to the direction of incident rays are taken as negative. So distances in this direction are taken as positive, while the distances in this direction are taken as negative. Fine. So all the distances in the direction of incident rays, here is the object, the rays of light are falling on the mirror in this direction, these are the incident rays. So all the distances in this direction are taken as positive, while as the distances opposite to the direction of incident rays, that is when we measure the distance from the pole of the mirror towards this side, fine, all the distances in this direction are taken as negative. So all the distances, if we measure the distance in this direction, if the image is formed here, so it would be positive, fine. So all the distances in this direction positive, all the distances in this direction negative. So these are the conventions, sign conventions or assumptions for spherical mirrors. The concept behind this is to get a numerical value. With the help of that numerical value, we would get the different characteristics of an image. So the first point was an object is kept to the left side of the mirror, fine. All the distances above and perpendicular to principal axis positive, all the distances below and perpendicular to principal axis negative, all the distances in the direction of incident light positive, all the distances opposite to the direction of incident light negative, and the reference point for measuring the distances is pole, or all the distances are measured from the pole of the mirror, fine. Okay, now there are some assumptions with it, that is the focal length in case of a concave mirror is taken as negative. While solving the numericals, if there is the focal length, if you are given with the focal length of a concave mirror, like you have an object is placed at a distance of 10 centimeter from a concave mirror of focal length 15 centimeter. So if it is the focal length is given 15 centimeter, but the mirror is concave, you have to take it as minus 15 centimeter. So that's what I wrote, focal length of a concave mirror is taken as negative. So the next point, focal length of a convex mirror is taken as positive. Focal length of concave mirror is taken negative. Focal length of for convex mirror is taken positive. Object distance. What is object distance? Object distance is the distance of the object from the mirror. For example, I kept the object at this point, so I have to measure the distance. The object is from the mirror, so I would measure it from the pole. So like this, for example, if it is 15 centimeter, this is the object distance, fine. The distance at which object is kept from the mirror, and it would be measured from the pole. So the distance of the object from the mirror is known as object distance. It is denoted by U. It is always taken negative. Like you can see that from the sign conventions, if we go measuring the distances in this direction, so we are going opposite to the direction of incident light, isn't it? We are going opposite to the direction of incident light, and all the distances opposite to the direction of incident light are taken negative. So focal length in case of a concave is, object distance is taken as negative. Similarly, focal length in case of concave, this is pole, this is focus of a concave mirror. So we would go in this direction. So it would be it is opposite to the direction of incident light. That's why focal length of concave is taken as negative. While the focal length of convex, this is pole, we are going in this direction. Here is the focus of convex, isn't it? So we are going in this direction, that is in the direction of incident light. So it would be taken as positive. So focal length in case of a concave negative, focal length in case of a convex positive, object distance is always taken as negative. Now if you get the value of image distance as negative, by calculating the image distance if you get the value as negative. For example, you get the minus 14 centimeter answer for image distance. Image distance is the distance from the mirror at which the image is formed. Fine. Okay. If you get the negative value, it means the nature of image is real and inverted. The nature of image is real and inverted, and it lies position in front of mirror. You have to remember these points. We would practically see, or we would see it with the help of a ray diagram in the next topic. But remember these, if you get the image distance as negative, if you got the value of image distance in negative, that means you have to write it down there that the nature of the image is real and inverted and it lies in front of the mirror. If the image distance comes out to be positive, if the image distance is positive, then nature is virtual and erect. Virtual and erect. And the position is behind the mirror. Behind the mirror. Like you are asked in the numerical, give the position, nature and size of the image formed. Position, nature and size of the image formed. So when you calculate the image distance, you would get two things from it, position and nature. And the size of the image is calculated with the help of a formula, which we will discuss in the next topic. So as for now, the image distance, if the image distance comes out to be negative, then the nature is real and inverted and the image lies in front of mirror. And if the image distance comes out to be positive, then the nature of the image is virtual and erect and it lies behind the mirror. So for solving the numerical, you have to keep this table in mind. This table in mind. So first thing, the focal length of concave mirror is taken negative, focal length of convex is taken as positive. The next point, object distance is always taken as negative. Image, whether the object distance you are taking in case of a concave or convex, in both the cases it is taken as negative. Image distance, if it comes out to be negative, then the nature of image is real and inverted and the position is in front of mirror. And image distance, if it comes to be positive, then the nature of the image is virtual and erect and the position is behind the mirror. So inshallah in the next topic we would see these things with the help of a ray diagram, and we would discuss the next topic, that's actually image formation by concave mirror. Thank you.